Welcome to Hamas. Today we'll be doing inclined planes. Now, a particle of mass 0.8 kilograms is released from rest on a rough slope that is angled at theta to the horizontal, where tan theta equals 2/7. After 4 seconds, the speed of the particle is 1.3 meters per second. Find the value of the coefficient of friction mu between the particle and the slope. Okay, let's write that. So now this is 0.8. Now this is take every value and name it. Name M. The weight values. Name N. And keep angle as theta. This can be mg sine theta, since this is opposite. This is mg cos theta, since this is adjacent. And with fourth triangles, it's always the same as the inclined plane. So if this is theta, this will also be theta. Now that we've got our forces labelled, we can work out the values. Now let's say, since the particle is released from rest, it's going this way. It's going this way. So A goes in this direction. Therefore, there's no acceleration acting where R is. So R minus M. So this goes down, this goes right. Since R is upwards is taken as positive, R would be positive and mg cos theta would be negative. R equals mg cos theta. And since there's no acceleration, it can take the value to be 0 at the end. This value. Now, can now solve for the horizontal. So, mg sine theta, and let's call this mu times r. It's going the opposite direction. Since it's going in the opposite direction, because subtract mu r, but we already know the value of r, which is mg cos theta. So mu mg cos theta equal to Now we can get rid of every m part. Since we can divide by m, since m is common to all variables. G sine theta and G sine theta minus mu G cos theta equals to A can now put mg cos theta onto one side, mu g cos theta onto one side, and now we can subtract A, get mu g cos theta on its own. All we need to get mu on its own, the coefficient of friction, is divide by g cos theta. Divide both sides by g cos theta, yeah. G sine theta minus A divided by g cos theta equals mu. So that's our formula. Now note that down so we can work it out. Now what we can do is, we know the value of tan theta, which is 2/7. And this means opposite over adjacent. So therefore it would be 2 here and 7 here. 2 squared plus 7 squared. And now we can use Pythagoras to work it out. So square root of 2 squared, 7 squared, give us square root of 53. Therefore, sine theta would be equal to, remember, opposite over hypotenuse is equal to 2 over root 53. Therefore, cos theta equal to A over H, which here A over H is here, so 7 over root 53. Now that we have that, we can go note that down and work out the acceleration. So one of the most important things to note is that the system is released from rest. That means originally it was not moving, and the initial velocity must be 0. Therefore, the final velocity should be 1.35, because that's the velocity after 4 seconds has elapsed. And we don't know A yet, Right, we can use the formula V equals U plus AT. Now, we can substitute V in 1.35, and we said U is 0, so we can ignore that, but can put 4A, since 4 is T, and 4 times A, 4A, so divide each side by 4, and A would be equal to 27 over 80. Now, let's go back to this equation. Now we put in this format so it's easier, because there's lots of numbers that will make this process much harder. So we got sine theta, which is 2 over root 53 minus 27 over 80, because we got A, over T root 53, and that will give us mu.